All right, let's get started. Welcome to week 3 of the Freshman Engineering Seminar. Just a few quick announcements. First off, again, just make sure and sign the attendance sheet when you come in and whatnot. We'll try and have that for you as soon as possible. We're going to keep up with the same schedule with the quizzes, so the quiz for this lecture will be made available. I'll probably be completing that this evening. It'll open up tomorrow, and it will close next Friday at 11 a.m., and all the quizzes will close 1 hour prior to the next week's lecture, so make sure that you get that completed. Now, I'm sure that some of you saw that there were some advising holds placed on the engineering students here. That's really meant just to ensure that everybody keeps on track moving forward with, throughout your degree, and just make sure that you're taking the right courses. And you should have plenty of time to meet with your advisor. What I'm going to do today, I have about 6 advisees in here, so if you all have a couple minutes after class today to just stick around and we can have a chat about your upcoming schedule for the spring, that'd be fine. But sound good? Okay, all right, so we're going to continue on with the same path that we've done in previous lectures. We'll have a main speaker, but first off, we're going to have one of our faculty introduce themselves. So our faculty for this week is Dr. Isaac Waite. He's one of our civil faculty in the area of water resources. He's going to tell you a little bit about himself, and so with that, let's hear it for Dr. Waite.
Well, this is a good-looking group, all these freshmen. Not all freshmen. I see a few familiar faces. Yeah, so I'm Dr. Waite. I've been at Marshall for 10 years now, and so that makes me one of the more senior engineering faculty members because our program has really grown in leaps and bounds in recent years. And so when I first arrived at Marshall, I was faculty member number 6. There were only 5 here when I arrived, and so I was 6, and now I think we're up to 23 and growing. So you've really come at a great time where the program is expanding and adding new areas and being recognized. And so as Dr. Michelson mentioned, my background is water resources, and I sometimes also teach environmental engineering courses. I'll tell you a little bit more about both of those areas in just a minute. The classes that you may see me in most immediately is occasionally I get assigned to teach engineering computations, which is a spring semester course. I frequently teach engineering economy. Students will sometimes take that as early as their sophomore year. And then very few people can avoid having me for fluid mechanics, although I guess electrical engineers don't usually end up in fluid mechanics, but many of the rest of you do. And I also teach a course for civil engineering students called hydraulic engineering and an elective, which is hydrology. So my office is over in the engineering building up on the 3rd floor where it's nice and quiet. But I'd be glad to have you stop by anytime you need help. If you're one of my advisees, you can pass by, or if you just have questions about environmental or water resources, I'd be glad to see you. Or if you just want to come and talk about maple syrup, which is one of the things I really like about West Virginia, is all the interesting, unique, outdoorsy stuff that we've got here. I didn't grow up in a rural state. I just grew up in the suburbs. And so when I had the opportunity to buy a home that actually had some land, and like suddenly I owned trees, it kind of blew my mind. And I thought, what am I going to do with all these trees that I own, you know? Well, the answer is, one of the things I did was I tapped the maple trees, and what you can do is boil down all that syrup in a pan, and you end up with, I've only got 8 or 9 trees that I tap each year, but then that's enough to give me about 2 gallons of syrup. And that's plenty of syrup for, you know, the annual cycle. If you're using more than 2 gallons of syrup a year, you've probably got a problem. So that's one of the things I really like about West Virginia. And maybe you've been here long enough that you take it for granted, but I don't. We live in a pretty state with a lot of really cool things, and maple syrup tap is one of them. Another one is hunting. And I sometimes hunt, but this was just me on a hike. I hung out with this deer, and then we went our separate ways afterwards. He's fine. Nothing to worry about if you're an animal lover. But I never hunted before I moved to West Virginia. It was one of the engineering professors taught me how to shoot a deer and gut a deer and chop a deer up and how to cook it and all that sort of thing. So I just ended up in a rural state, and I'm really loving it. But oh, that's Florida. We don't have alligators in West Virginia, but I took some of that West Virginia mentality down to Florida a couple years ago, and my brother and I got some alligators. By far, the best thing I like about West Virginia is the trails that we've got in this area. You may not appreciate it, but there's a network of interconnected trails that goes through Barbersville and Ona into Putnam County and beyond. The trail that I run on most often is called the Kanawha Trace, but sometimes I go outside of state to run. This is a picture from 2 weeks ago when I was over in Switzerland and France and Italy running on the trails that they've got over there. So I really love the outdoor lifestyle that we've got here in West Virginia. I got my doctorate degree at Purdue University. Purdue is a big school that's really different from Marshall. And probably there are more civil engineering undergraduate students than all of Marshall's engineering students in 5 years at a time. It's a huge program, and one of the things that I feel really good about being here at Marshall is the fact that we get to have more personal attention with our students than I got when I was coming up as a student. I very rarely would speak to my professors. Too many of our courses were taught by graduate students, some of whom didn't have their educational background in the United States, so sometimes there was a mismatch in communications and understanding of just a variety of issues. And so I really like that now that I'm a faculty member, I get to teach at a smaller school where the students can have more personal attention and better resources to get them towards that career trajectory that they want to be on. My interest is in water, and this is a picture from that trip I took a couple of weeks ago. This is the Swiss village of Lavartezo, and it's really interesting because it's marble and water flowing through that marble over just thousands and hundreds of thousands of years has carved some pretty interesting formations. I threw this photo in for Dr. Michelson's benefit because he's a structural engineer, and I bet he goes on vacation and looks at bridges. When I'm on vacation, I look at the water. When he's on vacation, he looks at bridges. And so here's a stone bridge in the Swiss village of Lavartezo. Here is a similar function being satisfied by a box culvert here in West Virginia. And my area of water resources is in a large part considering questions of if there's a river and a road is going over the river, how big does the culvert or the bridge need to be in order to pass a certain flow rate? Because if this is too low to the water line, then when the water levels are high, it'll flow over the bridge and cause damage and delay, and people will be stranded. And so I do some hydrological modeling to look at what happens when it rains and how quickly will a flash flood arrive in a given spot. And that's actually very closely related to what our main speaker is going to be talking about today, I would imagine. His background is in hydrology and hydraulics. And so in water resources engineering, we're studying applications of the water cycle. And it's a little bit more on the science spectrum of, there's science, applied engineering. So this particular course that I teach, hydrology, we focus a lot on the science of the water cycle to try and understand what phenomena are actually driving the flash floods that so often cause problems here in West Virginia. We also look at water network sizing, and so the pipe networks that delivers potable drinking water to your home is sized by a water resources engineer with a background in hydraulics. And one of the interesting things that's come up in the last few years is you may have heard of a failure of a spillway out in California. A couple of years ago, the water level got so high at a reservoir, I think it's called Oroville Dam, that the dam itself was fine, but they sent water down the emergency overflow spillway, and the water was moving so quickly, and there were some material issues with the spillway that it actually scoured and caused a lot of damage, and people were worried that potentially that scour could eat its way all the way over to the dam. So things were a little bit iffy for a while. And so in all of engineering, there are consequences to our designs and to our analysis. And in civil engineering, sometimes those consequences can affect thousands and hundreds of thousands of lives. Environmental engineering is focusing more on the quality rather than the quantity of the water and air and soil. So environmental engineers are using the toolkit that you learn as an engineer, the application of math and science to solve problems, and looking at ways that we can recycle and preserve our natural environment. And so again, here in West Virginia, we have some unique challenges that environmental engineers can apply their knowledge and skills on. We have a lot of mining operations that affect the state and have impacts on water quality. And so environmental engineers can help to restore areas that have been damaged and design treatment so that new areas that are being developed aren't quite as badly affected as the old ones. Here's an aerial photo of a wastewater treatment plant, and that's another thing that environmental engineers will focus their efforts on, is sizing of clarifiers and disinfection basins, and basically designing the process that allows us to discharge water into the same river that we're getting our drinking water from. And you may know that here in Huntington, West Virginia, our drinking water comes from the Ohio River, and also our wastewater goes to the Ohio River. And so all of the towns upstream of us have been flushing their toilets into the Ohio River, and all the towns downstream of us are getting their drinking water from the same place that we put our wastewater. So we really want to have this process figured out and designed well and operating smoothly so that nobody gets sick along the way. So an environmental engineer who's designing wastewater treatment will be figuring out how big the tanks should be, how much time needs to be spent in each of the tanks for the treatment process. It's an interesting problem, and I enjoy teaching those classes when they come up. I just wanted to again invite you to get in touch with me anytime I can be of assistance. There's my office location, email address, and phone number. So thanks very much. I'm glad you're here at Marshall as freshmen. I'm excited for you to be here. I can't wait for you to take some of my classes so I can rake you over the coals. But until then, I wish you well and excited to hear what Doug's got to say.
With that, I'm just going to turn it over to our main speaker. His name's Doug Hurt. He's with the West Virginia Division of Highways in their Hydraulics and Drainage Unit. Not only is Doug going to share with us some pretty cool stuff that he's been working on at the DOH for the past few years, but Doug, again, also represents the DOH, which is one of the biggest potential employers for engineers in the state of West Virginia. So it's definitely worth hearing what he has to say. With that, I'm going to turn it over to you.
Just the arrow makes it go forward?
The other side.
That side?
Yeah.
Okay. All right, so you guys are freshmen. It's exciting to see all y'all here. Part of my purpose, as Dr. Michelson said, was I may have a job for you in a couple of years, so I want to keep you interested, and I want to encourage you to do well while you're here, so then in a couple of years you are ready to come to work with us. I'm originally from Parkersburg, just up the river from here, and yeah, I guess I'm one of those people that flush my toilet so that you guys would have drinking water down here. So live in Winfield now on the Kanawha River, so big fan of rivers. So I'm glad to be here, glad to get to talk to you guys. I'm not a Marshall graduate. I actually went to University of Missouri at Kansas City. That's where I finished up my military time, so that worked out good. But I did get a picture of a bison. So one of the great things you're going to have here is tenacious instructors. These guys are going to challenge you to be the best and do the best that you possibly can. So you've seen two of these guys here. Also Dr. Na, who's he was doing some crazy thing with recycled plastic pipes and nano clay, because one of the things we're doing is if you've ever been in a corrugated metal culvert, you know that it's missing something. Typically, if it's as old as you are, it's probably missing its bottom because it rusts out. So we want to use plastic pipe, and then there's a lot of recycled going on there. But there's concern that once you make this into pop bottles and different things, and then you try to make it into a pipe, that the polymers won't be as good. So Dr. Na is trying to figure out how to use nano clay, little tiny pieces of clay, I guess, to make that pipe last longer. And of course, this is a recent picture of Dr. Waite here while he was in Europe. So civil engineers go and work everywhere. These are some places I've been as a civil engineer. On the top left there, you can see the U-2 spy plane, also has other names. And that was when I was in Korea. upper right is, I guess it's now Interstate 26, the A10 connector in the Asheville area where I got to live for a little while. And the lower left is Mount Fuji. And you may recognize all those things, but probably nobody recognizes the bottom right. Has anyone been to Knob Noster, Missouri? Yeah, Isaac's been there. Wow, that's awesome. So a lot of great trails there. You have to check it out. Easy biking because it's not quite as hilly as here. So as a civil engineer, you're going to design, build, supervise, operate, maintain all kinds of different projects and systems. And I like this picture. This is Charleston and the Elk River. So you can see there's a lot of different things going on there. You got the interstate where it comes together. So some structures guy like Dr. Michelson had to figure out the loads on those bridges, and a roadway guy had to figure out the geometry, and somebody from traffic said, well, we need this many lanes, and this is how sharp they can curve. Also, you see the wastewater treatment plant in the foreground in the bottom, railroad bridge, another street bridge, parking lots, all kinds of buildings. And one thing that you'll see that you don't think is about engineering, but it is, the ball field. When you guys have kids, you're going to be drug into volunteering to help with their sports. And you're going to get there and all these parents are like, how do we make the baselines right? How do we make the soccer field square? You'll know how to do that. So that's a good ancillary skill that you'll have from your training here. But engineering, you get to have lots of fun with math. So this is somebody's homework paper, I guess. You may recognize some of those partial differential equations, but I'm not sure what to do with them. There on the right, I stole this. I have to give credit to Dr. Waite for that picture. It's from one of his fluid mechanics classes, I think. But I thought it was interesting because as a kayaker, you know, I'm all concerned about, am I going to tip over? Because my kayak is only about 19.5 inches wide. And I'm kind of about this tall even when I sit down. So I had to study up on how high can the seat be, how wide does it have to be, and what's the temperature of the water when I fall in. And so these are all important things that you can apply to. So rewarding career choices, there's a lot of different things you can work on. I started my career in civil engineering doing drafting and surveying before I finished my degree. And I thought, well, you know, that's kind of like trivial stuff. But it's very useful to be able to draw and to be able to measure stuff outside and be able to handle the outside environment. Then I did environmental engineering. I worked on leaking underground storage tanks. I did phase 1 environmental assessments and all kinds of stuff like that. Then roadway design and structure design, geotech, and for the last 18 years I've been in hydraulics, so that's been good to focus on something fun. But you can go anywhere in the world and work as an engineer, especially as a civil engineer, but you can also work close to home because there's going to be a lot of jobs everywhere. And I say good pay, not great pay, but it'll be good enough that you'll be able to buy plastic tubing to tap in the maple trees in your yard, so you'll be okay. So the other division in career path is technical versus management. Most of us end up doing kind of a mixture of both. I have a small group of people that I supervise, and I also have a situation where I have to have influence over the whole state, you know, all the 10 districts and various agencies that we deal with. So, but I still have to be technically savvy, so I kind of have to do both. But you can, you know, be one of the little pinheads and be off in the corner and do all this really technical, crazy stuff, or you can become the boss instead, and then you don't have to know so much, but you have to manage people. And as engineers, how many of you guys want to manage people instead of doing math? Okay, so a fair number of you. That's good. And I think most of us eventually get to that point, some sooner than others, but just something to consider. And some of you will never work as engineers. You'll get your degree and you'll say, you know what, I want to go build houses, or I want to go sell cars, or something like that. So you never really know, and some of you may know, but most of you probably don't. Some of our projects are really pretty spectacular. The upper right there, I think that's the East Huntington Bridge. I'm not sure what, otherwise you call it, but big cable stay bridge, you know, tension on the cables there, and exciting stuff. The New River Gorge, we've got Bridge Day coming up soon, and that'll be an opportunity to go up there and have some crazy fun. But not everything is quite that exciting. Some of them are rather interesting, though. This bridge on the upper left here, this is in Upshur County, I believe. It's over the Buchanan River. I can't remember the name of the little community. It's not even a town that it's in. But this is a retrofit bridge that was done about 40 years ago. The cut stones, obviously, are from 100 years ago or more. But the beams that you see, do you think this stone abutment is holding up this beam? It's a real simple question, yes or no? How many people say yes? How many people say no? No. And you'd be correct, because you just have these little things that are scabbed on here to kind of make it look like it's all connected, but the reality is these junky looking bents that are down in the river are really what's holding up the beams. So just kind of crazy stuff like that. The pipe that you see on the lower right there, we're standing in a big pipe, and if I had a great picture where I could turn around and look the other way, you could see that there's an even bigger structure behind us. When I took this picture, it was a 10 by 10 box culvert, then a 6-foot diameter pipe, then a 4-foot diameter pipe. So it's kind of like a funnel, but that really doesn't make a lot of sense because we're going downstream. The amount of water is not decreasing. It's actually going to get steeper, so it kind of works. But this was just one of those crazy jobs where the road was falling in above it, and they didn't know why. So I went in the pipe and looked, and you could see why, because they didn't connect the 6-foot pipe to the 4-foot pipe. I got the plans out, and there was like a funnel that was to be constructed, but it's easy to draw. It's harder to fabricate out of sheet metal. So they said, let's send the inspector to lunch, and we'll just cram those two pipes together. And so the thing failed. So these are fun things we get to fix. So work inside or outside? How many of you guys want to work inside? Nobody. Everybody wants to work outside, right? So this is one of the great outside places. This is up in Fayette County, I believe. Chestnut Run or something like that. This is above Prince at the New River. And so this is one of the beautiful places we get to go and see. So Division of Highways, where I work, there's about 38,000 miles of roads, and you can do the math and figure out how many potholes would be included in those 38,000 miles of roads. Almost 7,000 bridges. So if we replace a bridge every 100 years, how many bridges do we have to replace every year? If a bridge lasts 100 years, we got 7,000. How many do we have to replace every year? About 69.58, right? I don't want to drive on that .58 bridge, but about 70 bridges. So that's a lot of bridges. So somebody has to design all those. Somebody has to supervise the construction of all those. So there's going to be a lot of opportunity to continue doing work. We're organized by a central office, and I'm in the central office in one of the divisions there, and that's located in Charleston. We also have 10 districts, and there's one here in Huntington, District 2, and famous or infamous, depending on your perspective. And also District 1 is in Charleston, District 3 is up in Parkersburg. I have an office in Clarksburg, Bridgeport area. Burlington, how many know where Burlington, West Virginia is? Yeah, one. Okay, are you from up that way? No, you just have been through there on Route 50 one time and said, oh, we're in Burlington. So it's kind of in the middle of the woods out there. Moundsville, also up the river. Weston at the Trans-Allegheny Lunatic Asylum. It's actually across the street from the place. But Elkins, which is a nice area. And then Lewisburg, which is God's country, except it stays winter too long down there. And then Princeton, down in the southern part of the state. And of course, county maintenance garages, but hopefully you won't get stationed there. That was always the thing. If you screw up, we're going to send you to the county maintenance garage to work. So my highways experience, my first 2 years were in roadway design, And that was a lot of fun because here I am, I'm going to work as a transportation engineer. I went to a small college and we had geotech, we had environmental, we had hydraulics, and we had structures. So here I'm going to work as a transportation engineer. I've never had a transportation class. Fortunately, I could fall back on my surveying, so I understood what stationing was, and I knew how to calculate a point on a curve, so I was okay there. That was a lot of fun, got to meet a lot of people, do a lot of different things. Then 10 months in consultant services. They said, we're going to move you there. Why do I want to do that? It's about writing agreements and negotiating prices, and I don't know. I got to meet a lot of fun people, but you can see I didn't last very long there. So then 3 years as a structural engineer. That was fun, but at some point I realized that at that age I was never going to amount to anything as a structural engineer designing these little two-span, 200-foot-long bridges. I was never going to get to do the New River Gorge or an Ohio River crossing. So from there I went on to hydraulics, and that's a lot of fun. I get to play in the creek, bridges, culverts, storm drains, ditches, everything having to do with water. And as Dr. Waite said, mostly it's water quantity that we deal with. Where was that culvert that you showed, that box culvert with all the...
Not sure.
Not sure. Okay. It's like, that's pretty cool because it has some things in there that we do to help with fish passage and sediment transport, and that doesn't get done everywhere. So that was a good one to see. So obviously I've kind of stuck in hydraulics, and I like it there, and so that's been a good place for me. So I've worked in all 55 counties. I've been all over the state, some more than others. And we do everything from simple ditch design to the longest bridges. This is the Blennerhassett Bridge over the Ohio River. The main span that you see here, this tight arch, is just over the main channel on the Ohio side. There's also a back channel. And if you were to look further to the right, you'll just see a standard deck girder that goes on across to back to West Virginia. Bike paths to interstate routes. You know, we worked on the interstate here to widen it so that I wouldn't have to spend an extra 20 minutes every day getting to work. Thank you very much. And then the bike path you can kind of see in the background there. I guess the animation didn't work. You wouldn't think bike paths have anything to do with people that are funded by gasoline tax, but fortunately, for those of us that like to ride our bikes, we do have some involvement in bike paths, especially like with Corridor H. There's more or less a bike path constructed along most of it. There's some places where they say, you can just ride on the highway. And when you get over toward Burlington, that's kind of true because there's not very many cars, so you're safe on the road. But like through Elkins and Parsons in that area, there's a lot of nice trail there. So some of us work in the office and some of us work in the field. Most of us do both. I probably get out in the field about 3-4 days a month is about it. And you can kind of have some influence on that, not completely control that. If you want to work in construction or maintenance, you'll have more time in the field. So functional areas, design, the roadway, we kind of mentioned this earlier, is about the geometry. It's about the pavement, making sure you can get the cars through. Structures, of course, bridges and large culverts that they'll deal with. Geotech, everything sits on the ground more or less. So they deal with the soil, make sure the soil doesn't slide into the river down the hillside. And also our bridges are all founded on rock, so we rely on the geotech folks for that to say how deep is rock, and oh, by the way, is this rock strong enough really to hold my bridge up, or is it, you know, some crumbly shale that's not going to last? And the hydraulics, everything to do with water. How much does it rain, which is hydrology, and then what happens when it hits the ground and starts flowing, hydraulics. Construction, everything's got to get built, and you'll have a class in materials at some point, and you wouldn't necessarily think that materials is engineering. It's more of a science thing, but you have to do some math and you have to do some testing there. So that's a place where a lot of people specialize: concrete, steel, different metals. Maintenance, you really have to take care of stuff. And who would rather build something new, or who would rather take care of something that they already have? How about build something new? You know, that's where the excitement is. That's where the fun is. Until you drive over a bridge that says posted for 3 tons because the section of the beam has rusted in half, or you hit 40 potholes going down your street and you say, you know what, maybe this maintenance is something we should pay attention to. And I think it's an age thing. I find the older I get, the more I care about maintenance, and the less I'm beguiled by the excitement of creating new. Planning and traffic. So traffic. Have any of you ever driven in a traffic circle or a roundabout? Have you ever driven in one? So this one obviously is not here because what do you think is the design flaw with this roundabout? Can you tell by looking at the pattern? So obviously we're going counterclockwise is the flow. So who has the right of way here? The car's coming in or the car's trying to get out? Should be out. But look at this bus right here. He's got this all blocked so none of these cars can leave. So this thing just gridlocks. Even though you've got, what, 6 or 8 lanes, you don't have a lot of capacity there. But you got to be able to get out of the way before you can let more people in, and that's how they had it backwards. So they need stop signs where you enter and go signs where you're trying to get out. So I just thought that was an interesting picture. So whenever you design traffic circles, make sure you put the yield signs in the right place. So the engineering cycle. So this is great. This is where our curiosity comes in and our technical skills come in. So we want to figure out what are the problems, what are the constraints, what do we need to fix, and where are we limited on what we can do with this. And so brainstorming ideas, this is fun. This is my favorite part, is just trying to figure out, how do we do this? How do we come up with something? And you're always going to come up with several ideas. Then you got to pick which one are we really going to do. And then you draw pictures and get what you need to do it and follow through. And then you can kind of rework and you can go through this whole process. And as engineers, you can just go round and around and around in a big circle here. And it's a lot of fun, but you may not ever get anything done. So remember, and this is posted, my brother works at a plant somewhere, and he has this on his toolbox. And two of the brothers are engineers, and he's a worker. So he says, in every project there comes a time when you have to shoot the engineers and start production. So keep that in mind. You know, you can do fun stuff and say, wow, well, what if we tweaked it a little bit more and did this? Eventually, you got to go to work. You got to get it built. So another organization we have is within highways is planning, and they produce these nice maps for us. You notice they've changed a little bit in the last couple of years, and they also coordinate with metropolitan planning organizations. I'm sure Huntington has one here, probably includes a wide area, and so there's a lot of kind of big picture. Doesn't really get into the nuts and bolts, but hey, you know, there's too many cars on Hal Greer Boulevard. What do we do? Do we just make them drive faster so they get out of the way sooner? Or do we build more lanes, or do we send some of the cars down to the next exit and come through? That's the kind of big picture ideas that they're focusing on. So in design, we get to draw fun stuff. So this is from our CAD program, computer-aided drafting and design. And this is a lot of fun because you see the parallel green lines that run through there. That's our road. And all those crooked kind of pale green lines, those are the contour lines that show how steep the hill is. So this road is actually in a coal mine area. So you can see those contour lines are real close together, which means it's straight off. So, you know, we're trying to figure out the cut and fill. And if we move out to the left, we have too much fill. If we move to the right, we have too much cut. So with the computer drafting program, we can tweak that many times and try many iterations without having to redraw it all by hand. So it really saves us a lot of time and gives us more time to go around that circle more times than the builders might like. So this is just a screenshot of an antique computer program that we use called HECRAS. When I started, this was like the hot new thing, and I was all, I figured out how to use this before anybody else here, and so I was on the cutting edge. You know, 20 years later, it's not cutting edge anymore. So we're moving toward 2D models, two-dimensional flow models, and watershed modeling systems to figure out our hydrology in more detailed ways. One of the good things about now to be an engineer is all the great things we thought we could do 20 years ago that we didn't quite have the computing power to do and didn't quite have the data available to do. The computing power is here and the data is coming. We're getting LiDAR for the entire state, so we'll have a good detailed 3D map of the ground of everywhere in the state, which will be really nice, and that'll help us to apply to these new programs that are coming online. So construction, this is in another town that will remain nameless. And when we drew this road, we didn't put that little kink in the guardrail there on the right side, but they had to work around something, and so that's how that ended up. But this is an amazing project. They had a deadline. They had to get it done before kickoff, and I think they started in June, so that didn't give them a lot of time. This is a big job. So we went out there like the day before it was supposed to open, and we saw 14 pieces of equipment moving everywhere, and fill being placed in lifts about this thick with broken slabs the size of that table. I was like, well, where's the inspectors? I don't know, but so be careful when you come off the mile ground. So you can work in the central office or the district, as I mentioned before. And so the district office that you see there, that is Burlington. That's the biggest building in the town. And of course, that was my view from the Capitol before they moved us out of our offices there in Building 5 in Charleston. But, you know, we landed well. This is not quite the view from my office since I'm in an interior office with no windows now, but we're right across from the ballpark in Charleston, so that's pretty nice. So this brings me to you. You can begin your career at the Highway Department. The first thing is, after this year, you can work as a co-op, and your professors will be telling you when to apply. It's usually like mid-February you've got to apply, and I know, you know, you'll be scrambling around to work on projects and get your homework done and exams and all this and that. You say, that's not till summer. I can put that off. Don't put it off, because we do have a deadline and we've got to place people. So it's a great opportunity to get a summer job. Pay is $11 to $16.50 an hour, and so it's probably better than McDonald's, and it's relevant work. It'll give you an opportunity to try us out, give us an opportunity to try you out. You'll get to work probably in construction. Maybe you get to work in some design a little bit, maybe in planning. And I think it's really a good summer job opportunity. And they have folks in all the districts that I mentioned to you. And so I would encourage you to look into that, especially if you're. We have opened up. Basically, we're civil engineers. We have a couple of electricals, but we've opened up our career opportunities to mechanicals and I think electricals as well too. So I presume you'd be eligible for the co-op program. But if you want to try to get something more specific to electrical, that's fine. So then after that, we have scholarships. So if you've co-opted with us a couple of years and you think, I kind of like this highway stuff, maybe I want to work there, but I'm running out of money to pay for college. We can help with that too. So this is a great way to get kind of your last year paid for, and then to have a guaranteed job, almost guaranteed job. If you behave yourself in your co-op, you will have a guaranteed job. We have turned down one or two people at co-op that were scholarship students that we had promised them a job, and we said, you know what? We have all these papers that say we don't want you to work here because of your attitude and your work. So wherever you go, whatever you do, whether you're working at highways in the summer or whether you're serving hamburgers or making pizzas, your work attitude is crucial, and that's going to be important. And don't think that those minor jobs are not important to developing toward what you want to be. You think college is the thing, but all that other stupid little work that you do is important. Your work ethic is going to be just as important as what grade you got in chemistry. Probably more. So our starting pay, I think this is still correct, $47,000. So that's not terrible. And if you just go to West Virginia Division of Personnel, you'll find the job seekers website. You don't have to write down this address or anything, but you'll find it. And you'll need to apply. All the applications are done online through this, through the Division of Personnel. And what we do then is we say, hey, we need to hire some engineers. And so we tell the DOP and we put out an advertisement, which really is kind of, I don't know, a trivial thing, because what we're going to do then is once that posting comes down, we're going to call the DOP and say, hey, send us the register, send us the list of people that applied already. And as far as I've seen, those applications have to have been in before we even advertise. So when you get in your last semester, or maybe like Thanksgiving before you graduate, go ahead and apply as a highway engineer trainee. Don't get confused. They also have an engineer trainee. You want to apply as a highway engineer trainee, because that's what those are the applications that we'll see. It's all online. You just put in your information, and then we'll call you and say, come and talk to us about going to work. And back to the co-op thing, that's probably one of your best opportunities, because the people that you've already worked with in the summer, that you already have a rapport with, they've already seen your work ethic, they've seen how smart you are, they'll want to hire you, mostly. So, you know, that's a good way to get started. So get more out of college. Here's advice you probably never heard before from your parents or your teachers. But anyway, I'm going to say it again anyway. So do your homework. In high school, your homework was important because it was biggest part of your grade. When you get to college, the professors say, I don't care if you do your homework or not, because I'll be able to tell on the test whether you did your homework. So especially if it's not going to be collected, make sure you do that stuff. And write class notes by hand. Some of you may have photographic memories, or you can just remember stuff. That's great. You may take notes on your device, but I found, and studies have shown, that if you write it out by hand, it helps you remember better. Develop your writing and speaking skills. As engineers, we think it's all about math and it's all about science, and that's really the most important thing. But the longer you're in it, the more you do writing and speaking as part of your job, and the less math and science that you're going to do. So when you get into your mid-level classes and your upper-level classes, you're going to have group projects that you're going to do. And there's somebody in your group that's going to be, you know, rock, paper, scissors. They're going to have to do the report, and they're going to have to give the presentation. And engineers, no, I don't want to do that. That's too scary. Do it. Do it. It'll help you in a lot of ways. Not only will it help your grade in the class, probably, but it'll also prepare you for later on, because everything you do prepares you to do something else later. And so don't back out of any opportunities. And you're also going to have fun projects to do here. And it doesn't count toward your grade, and it might compromise how much study time you have, or whether you can go to the pep rally or whatever. But do these extra projects. Build the steel bridge. Paddle the concrete canoe. Are there other ones you guys do here? The Baja for mechanicals. I wished I'd stayed in mechanical. That would have been fun. But do those projects. That you will learn so much from that, and you know, your team working skills will grow from that. Have the college fun a little bit, but make sure you don't have to try again later. So wrap myself out here. I went to college for 2 years, and it didn't work out for me. So I spent the next 8 years working to the point where I could go back and finish. So make sure your focus is not having the college fun, but focusing on getting through your classes well. And take the Fundamentals of Engineering exam as soon as you can. I'm tired of interviewing graduates that say, oh yeah, I'll take that sometime. Now electricals and mechanicals, you guys probably don't fool with this, but civils, take the stinking test, okay? Because if you come to an interview and say, well, you know, I'll take it sometime. The reason that's important is because as civils, you have to be a licensed professional engineer to be able to oversee work and to be able to stamp work and say, yeah, this is really engineering work and this is really good stuff, and we can build it from this and it'll be good. And so that Fundamentals of Engineering exam is the second step on the way. First is your degree. Second is taking that FE. and then working for 4 years, and then taking the professional engineer's exam. So when do you guys recommend they take the test? Senior year, okay. I think the test has changed since back when I did it on stone tablets, but then it was mostly a sophomore test. It was all about fluid mechanics and chemistry and calculus, and so now it's more, so take it in your senior year. All right, so does anybody have any questions? And you can't go to lunch until you have questions. Yes, sir. I do. That's not really a question, so we need some more.
Somebody out there. Here we go.
Yes, yes, ma'am. I have. Was it?
The train goes over like a car tunnel, and then under the car tunnel is water, and that one.
Yeah, I know both of those structures you're talking about, yeah. And so this morning I'm working on a flood study at Berkeley Station Road. You know where that is?
Yeah, we don't put the Berkeley in it.
Okay, just call it Station Road? Okay, I'll have to fix my report then.
Well,
So
it's probably in there, but we just don't call it Berkeley.
you just call it Station Road. Okay, so, and one of my colleagues did the hydraulics on that structure at Memorial Park. But yeah, we're doing a lot of work on flooding. And so now I've lost track of what your question is. I was enjoying your tour of Martinsburg.
I was just asking because I'm not familiar and I'm not really interested in those things, but now I am because I realize how
It's working.
and I'm just curious about, the state of those structures in probably like 5 years. But they're all in very popular areas, like the MARC train goes over that railway where the bridge keeps getting flooded.
Mm-hmm.
It's a tunnel, so you can't really see it in the dark, and many people's cars have been destroyed.
Gone into the water.
Yeah, just going straight to the water because you can't see it.
So these are all things we're working on. And we're trying to figure out. The problem with Martinsburg, how many of you have been to Martinsburg? There are places in Martinsburg where there aren't creeks. And that's because it's karst topography, which means by rock, which is limestone here. And so the water just kind of soaks in the ground. And when there's no pavement and no roofs on it, and start building houses and we start paving over, and then the water starts to flow on the surface, what has nowhere to go, and floods neighborhoods and houses and creates big sinkholes that nobody wants to deal with. So yeah, Martinsburg is a very exciting place, and I'm hoping you can give me some good answers for this study. I'm repeating a study that the county did 20 years ago, and they did a good job of characterizing the problem, saying, well, this is what's wrong, and then their paragraph about how to fix it, we never followed through with that fix. So it makes it interesting. All right. So that's not really a question either. So you're still not off the hook.
Any questions?
Yes?
What's your favorite project that you
Favorite project that I've worked on? Man, there's so many fun ones. The Blennerhassett Bridge that I showed, that's one of my favorites. We'll get to do hydraulics on that. It was fun because the original design was not the tight arch that you see, but it was to be a suspension bridge, to look like the old Parkersburg Bridge that was torn down 20 years before you guys were born. But the spans were all out of whack. It was designed by politicians and roadway engineers. And finally, with the help of the hydraulics engineers, the structures people finally convinced them that, hey, this is not the bridge you're looking for. You need to build this tight arch instead. So that was kind of fun. The other thing that was fun about that was, had it been built in time, it would have cut down the time it took for me to drive to my grandma's house from 40 minutes to 10 minutes, but it was built too late. So I guess that's probably one of my favorite projects. Just any project where we get to use our skills to come up with something better than what we would have done otherwise.
All right. First off, let's give Doug a round of applause. Two more things before we close. Don't forget the quiz, which is going to close next Friday at 11. And again, if you're one of my advisees, if you wouldn't mind sticking around for a few minutes, that'd be great. That's all we got. Y'all have a great weekend.